All right, Calculus, welcome to your 6-1 areas between curves video. This is day number 3. I think your third video here. What I want to show you first is the situation we're looking at in the 7th edition book here. We talked before, area is the integral from a to b, y top minus y bottom dx. I have a situation like this I showed you in the help lesson the other day. All right, where we have maybe a curve like this or this. And we would have not really a y top situation or a y bottom, but we'd have an x right, x left situation. So notice how this function is always to the right of that function there. Okay, and then we use as my bounds some y equals d, y equals c. So right there, y equals d, y equals c. All right, so that would be this situation right here, where area is the integral from c to d, x right minus x left, dy. Okay, so now you have these two situations, what we've been working with before. Area is the integral from a to b, y top minus y bottom dx, or we'll look at, I think, 5 of these today. Area is the integral from c to d, x right minus x left dy. And after some practice, you'll just be able to tell which of these to employ. Number 1, find the area enclosed by y equals x minus 1 and y squared equals 2x plus 6. Here's the first. This one should hopefully be relatively easy to see. What I want to do here, the least amount of work. I mean, I guess I could square. I can both look the same. I could square both sides here. But if I try to get y all by itself here and take the square root, I'm going to have plus or minus the square root of 2x plus 6, and that's going to be no bueno. So instead, right here, if I know that y equals x minus 1, and just add 1 to the other side, I know that x is y plus 1. Okay, now I have something x equals. Right here, if y squared is 2x plus 6, then I can subtract 6 from both sides, then divide by 2. So 2x would be y squared minus 6, divide by 2. X would be 1/2 y squared minus 3. Okay, now I'm going to set 1/2 y squared minus 3 equal to y plus 1. Y plus 1 equals 1/2 y squared minus 3. Going to move the y and the 1 over to the other side. I have 1/2 y squared minus y minus 4. I'm going to double both sides to then be able to factor that. You guys should know how to factor that easily. Y minus 4, y plus 2 is 0. I get y equals 4 and y equals negative 2. That is bounds, negative 2 to 4. So my area would be x right minus x left dy. Okay, the independent variable there, what I'm working with is y. Okay. Then I need to figure out what x right and x left are. So given x equals y plus 1, and x equals 1/2 y squared minus 3, and the bounds are negative 2 to 4. I got to pick a number for y that's in between negative 2 and 4. How about 0? I'm going to plug 0 in there, and for y there, I'm going to plug 0 in for y there. So x equals 0 plus 1, then x equals 1/2 is 0 squared minus 3. 1 is bigger than negative 3, and on the x-axis, 1 would be to the right of negative 3. So this is x right, that's x left. That means this one right here is x right. This one right here is x left. So now my integral is bounds negative 2 to 4, x right minus x left. Clean that up. I just take the antiderivative, 1 power up divided by the new power. Plug in 4 to my antiderivative minus plug in 2 to my antiderivative. Again, plug this whenever. Try to remember to take photos in the next few days of this. Plug 4 into my antiderivative minus my antiderivative evaluated at negative 2. It's just arithmetic time. It's going to give you a nice answer of 18. The area there is 18. All right, so again, pause this whenever you need to. That's the name of the game. That's what we're after, sorry, in this video. Find the area of the region enclosed by the given curves. Y equals the square root of x minus 1. X minus y equals 1. Okay, so again, you can always, do a little guess and check as to whether you're going to do a y top minus y bottom, x right minus x top, sorry, x right minus x left type of deal. Here, though, I can get x all by itself on both sides relatively easy, especially on this one on the right. Just move the y over. Right here, if I square both sides, I get y squared is x minus 1. Add 1 to the other side, I get x equals y squared plus 1. So then, if x equals y squared plus 1 and x equals y plus 1, I would set those two equal to each other. Move over the y, the 1's cancel. This one factors really nicely. You get y is 0 and 1. So you know that those are the bounds. Area is from 0 to 1, x right minus x left, dy. What can you pick between 0 and 1? I guess a half. So you're going to plug a half in for y right here and a half in for y right there, which I've shown here. 1/2 squared plus 1 is 5/4. 1/2 plus 1 is 3/2, which is 6/4. So this is x right. This is x right. The second one, which is right here. This is x right. This is x left. And here is my integral. All right, x right minus x left. Clean that up a little bit. Negative y squared plus y dy. Bounds from 0 to 1. 1 power up divided by the new power. And then you only have to really just plug 1 in. Negative 1/3 plus 1/2 is a 6. The area is a